Hi, everyone. Happy to see people in real. Happy to be here to talk about Koin with you and to share this moment with you today. Let's talk about Koin today. Just about myself in a few words. I'm Arnaud Giuliani. I'm working at BlaBlaCar, a company based in Paris. I'm also a Google dev expert in Kotlin. I'm the crazy guy that is working on Koin in this free time. And you can also follow me on Twitter if you want to ask things or many stuff. Just one word about BlaBlaCar. BlaBlaCar is a carpooling application that is available in 22 countries. We have more than 100 million people using it. And then it's about carpooling, and not only. We have also buses and many ways to try to share travels. But today, we are here to talk about Koin. And it's been a long time. I didn't give some news about Koin in real conferences. And let's say that. What's up, Koin? Yeah, the project, if you remember, it has been started in 2017. Still here. Still people using it. Today, it's 7K stars on GitHub. It's migrated on Maven Central. Yeah. It's around 5 million downloads a year, something it's interesting. And since last year, I would say there's many new incoming stuff that is really interesting. Are there people that are still using Koin in the version 2 here in the room? Just raise the air. OK, just a few. Perhaps the time to think about migration, because Koin 2.x is the old stable version, and perhaps you can follow the link to check that, but take time to upgrade, please, because we have many fixes, improvements you will enjoy. Then in Koin 3.x, there's the major things here is that finally we've merged back some of the modules, the Gradle modules that were view model, scope, and unredux fragment. And as you may see, you don't need anymore to bring them in your Gradle file because everything is merged as the main Koin Android module. And then everything in the cycle of development is kept in this module. Then if you upgrade from 2 to 3, you can have some weird stuff about do not find in one of those packages. This is because this has been taken out from the version 3. Then soon, one of version is 3.1.3. The current version stable is 3.1.2, but here we are working, and I will show stuff that are available in 3.1.3. I would like to come back to core concepts. As today, I would like to go on architecture design and help you write your application with Koin and understand how you can easily fill it. But I could just say, hey, just use Koin, and it's super easy, and you could say that. But Koin, if you just to give you some clues, is just about a DSL. A DSL to help you declare things. You see the module, single stuff. And when you use the DSL, then finally everything is constructor injected. That means that your classes are directly called in the constructor. Then it's created by the Koin container. And the two classes that we have here, thermosiphon, electric heater, those two classes, they are not dependent on Koin API. Then this is constructor injection. The other concept that we use in Koin is the Koin component. It's usually an interface that you can use. It opens up an access to the buy, inject, the magical expression, and the get function. And also this Koin component interface, it's provided directly as an extension itself. Then it's kind of magical to find it directly in the Android API or as is, because finally we can provide this Koin component interface directly for you. You don't have to use this. In a classical Kotlin interface, when you use extensions to retrieve your instance, finally, the host class is not created by Koin. You are creating it, or in your Android application, we are following the lifecycle, the well-known lifecycle of Android then. And then you are retrieving your instance. It's where you finally use the locator pattern. It's to give you a clue of how you build stuff, how you configure things, and how finally you can split the things in what is really the things in Koin there. And Koin is made to be super simple, and please make your configuration file super simple also. Okay, then building an MVVM and MVP app can be interesting to jump on a sample that is, let's say, perhaps well-known. It's the Android Blueprint Architecture application. This is an application that is made by Google and GDE people. You can find the following links here. And it's to demonstrate patterns, architecture patterns, MVVM, everything around. And you have the fork on the GitHub of Koin, insert corner your architecture samples here, where you have the version using Koin here. And we will see how we can do, what we can do about that. Then, just to use the samples I will show you here, I just need one dependency in this version. This super great application of to-do is an application that is listing to-do, and then what you do is just adding a new to-do in your list, and then it follows up the stuff, and then you can add things, then you can go in details, add a new one. But here today, let's just focus on activity and a fragment, a view model, okay? Then a task activity, a task fragment to make the UI, to make the list. The view model to begin to retrieve data against a task repository. Behind this task repository, we have a task data source, that is the remote data source that we are calling a web API, and the local one that is using a room database. This is something that is more or less classical. This is something not really complex in terms of architecture, and this is the basic architecture that you can find in this Android Blueprint architecture sample here. Let's start. Then, when you begin to develop your application, you begin to write your layers, and finally we start with the first class, that here is a task remote data source. You may see it's an object here. And how you want to declare it in Koin is just one line. Here, I won't show the module side, but we focus on definition. Is here we just write single, it's a keyword, single of task data source, and you have a lambda calling the construction of your object. And then just write single of task data source of the current class's task remote data source. You need to give an extra type of this object. Why? Because finally, in Koin, we don't want to make introspection. We don't want to make magical behind the things. We want to go straight to the point. And then here we want to say to Koin, here, this is an object, this is an instance of type task data source. And that's it. You have your lambda writing your stuff then. If we have another data source, let's say the task local data source here, you have a constructor here, classical one where we want to use a task DAO, a coroutine dispatcher. How we can do that in Koin is that we also use a single. Single means that we will have a singleton instance in Koin. And then we have a lambda to construct the task local data source here with a get keyword to say to Koin, retrieve the things for me. And then, as we have two definitions for the same type, if you try to ask Koin about, hey guy, give me the task data source type, he won't understand what you want to resolve here. And this is why we have this extra function here named that is a qualifier, something to give a name to your instance. And this way, we can resolve and differentiate those two definitions for the same type. The task repository here, you see, finally, it's just a class with the two data sources and a coroutine dispatcher. And this is how we can write it with the Koin definition, the DSL. We just say single of task repository, and then we instantiate the default task repository classes and then we fill the constructor with the get functions. And then here also, I need to put named to be sure I can make the difference between the two type of data sources. And you see, finally, it's super quick. You just write single, my type, a lambda, and the object I want to build here. Regarding the task data source, as Koin is a Kotlin DSL, that means it's compiling with your code. This is not a meta language or something. This is Kotlin language, Kotlin library, built up in a DSL way to help you build something in a simple manner. And finally, to build a room database, I can write this, room database builder. And if you see in orange, it's an Android extension function, something that is provided by Koin to say, OK, you can use the Android context that is available here. And then in one function, I can declare my room database instance. And it's super easy to declare the given DIO in that with just one line. We just say single of, we get to the database instance, the thing that we just declare above. And then we call .taskDIO on it. And then it will just call the taskDIO instance, and then we can export it as a Koin instance. Then we have the data sources, the repository. We have the database. Here now we can use the view model. Then we begin to have our data layer. Then here, the task view model. Here we have something that is also classical. We just use the task repository dependency here. And we have also the save state handle property that is passed to your view model, something that lets you write and persist data between recreation of your view model if you need for process handling. And this is the way you declare your view model. Just view model. It's another keyword of the Koin DSL. And your instance of task view model with the get functions. And that's it. You don't have to write your factory. You don't have to wire other things. The only few keywords you have to know with Koin is the module keyword to open a module. We'll see that later, but it's about, after that, single, view model, factory, and get in your constructor to say to Koin to say, OK, when you construct this, resolve this for me. And finally, in the UI, if we want to use our view model, we just use by view model, not the by view models with the S at the end. That is the Google API that has been launched a moment ago, but the by view model is the Koin API that lets you resolve. It's a lazy expression to let you resolve the view model creation behind that. Then you have filled the stack of creating your application. And then if we talk about MVP, and I have a presenter here, sorry for the green. Let's say we have a task presenter class where we want to use the task repository, and also we need a view. We inject the view as a presenter. The presenter we will observe the view and interact with the view directly, contrary to the view model where you finally just expose streams to interact with the view. What you can do here is that we won't use the view model key to declare a view model instance, but we will use the factory. It's the third keyword that you have to keep in mind is single for single instance, factory for things that has to be recreated if needed, and then view model. And you can see the lambda functions here. We have a first parameter that is the view that we want to pass to the function to build. And then we have your task presenter class here. And then we use the get function to retrieve the needed dependency. And then we can use directly the view value that is passed to this function. And this is a convenient way to finally pass something into your dependency graph from the caller point. How you do that? If you have your task fragment that is implementing the task view interface as your MVP pattern, what you can do is finally you use by inject to have a normal, let's say, way to inject your dependency. But you open a lambda and size parameters off, and you can point new value here. And that means that when you want to retrieve things, you can inject directly variables or stuff you can pass directly to the constructor of your object. Organizing modules. In Koin, finally, you are not limited to something that must compile directly because Koin is runtime and it's completely dynamic. You can organize yourself, but at the end, your application must run somewhere. Then up to you to organize your modules with layers, features, whatever, depending on your granularity, choice, or testability. If we want to go deeper in terms of architecture design and, let's say, put it into the clean architecture. This is the classical stuff that everyone sees when you talk about clean architecture. It's this onion graph with inner circles, and then each external layers has just to call the inner circle layer and etc. That means that our presenter layers must use a use case to wrap its business logic to wrap its business, to have this business layer to call and to be used by entities. For the application here, how it finally impacted, we have an extra layer of use case or interactor. It's the same. It's a logical piece finally where it's gating your business data. And in our view model, finally, we just changed the dependency from the repository to the use case. It doesn't change anything for this definition. But for the use case, finally, we have a class use case that needs the repository. And what we will do here is that we use factory. Why? Because we don't want to hold it in memory. When we want to use single instance, singletons, it will be held for your process. It will be held in memory. And then it won't be garbage collected if all this view is behind is used. Then let's wrap up to have a big picture of what we just seen there. It's our application layer components. Finally, for the presentation layer, what we need is to expose components as factory or view model. That means that it will be created just once when finally the UI is demanding a new instance. And all the underlying layers will be finally singleton. Okay? It's pretty easy to see the big pictures and to see where finally we are pushing singletons instance because we want to keep repository in memory, to keep data sources in memory, to keep your database instance and Room API in memory. And finally, at the top level, at the UI level in Android, we are just using Koin API. And for the use case, we'll introduce something that is created by a factory. That means that all the green and pink layers, they won't be held in memory by Koin. That means that when your UI will go down and be garbage collected, all your presentation layer will be garbage collected, all your use case layer will be garbage collected. And this is classically what we want to do to not make memory leaks. Let's go for more deeper topics, because this is usually what we do when we talk about scopes. Yeah, what is a scope? A scope is just a space where we try to maintain instance for a duration of time. And at the end of this time, we just want to drop everything. And why do we need scope then? Because we want to keep the same instance, the same organization of instance for all the same objects and for the specific time. That means that for the Android scope, then, we want to maintain a set of instances around your Android component lifecycle. Without scope, then, let's speak about a first usage. That means that we just inject a presenter here, okay? It's a factory. That means that, finally, when my activity, the myActivity class here, will be destroyed, then my presenter instance will be dropped also. Then everything is garbage collected. Ciao. Then we don't use scope here, and we don't need it, because finally, my presenter is just directly created by the UI instance. No other component is using it. In the case of we need an Android scope here is, for example, if we have another component that is using our presenter here, we want to be sure that we use the same presenter instance as the activity and the same in the myAdapter class. And this is where we need scope. We need a special space where finally we say, okay, we keep all these objects for the myActivity until myActivity is dropped. And finally, you see that we use a special class here, scope activity, that is something provided by Koin. We'll go back on it after. And the scope activity is finally the app compat activity that provides you a superpower to start a scope, Koin scope. And in terms of DSL, we just declare a block scope of myActivity type, and then we declare not single nor factory instance, but scoped instance. That means that for this given myActivity space, we want to keep myPresenter instance and myAdapter instance. And then we can resolve stuff with the get. And then we are pretty sure that the myPresenter instance will be the same in myActivity, in myAdapter, and everything, as long as finally we are working on the same myActivity. Because finally here, it's following the activity lifecycle. And then if you have a configuration change, then everything goes down because we are not a view model. And then we don't recycle things. And then everything also is still dropped, and we lose the instance. And when the activity is recreated, we recreate new instances. If you really, really want to be sure to not lose things, you may use something that is more easy to use by definition without a scope, that is view model. But you can use a view model inside a scope. That means that in my definition of scope here, I can use a view model directly, and myAdapter will have the reference to the view model. Okay? That means directly that when finally I have a configuration change, everything is recreating, I will lose my myAdapter instance, but my view model instance will be recycled, and we will keep the same stuff. And this is, you see, a gradual way to see scopes done from nothing, if you really don't need it, to something that is a middle, to finally something that is more resilient to changes with the view model. In terms of scope API for Koin, either you can directly use scope activity, and you see it will trigger all the API for you to retrieve the right definition of scope and says, okay, Koin, look at my activity, we have a scope, and then you see that by inject will by default look at your activity scope. Else, if you don't do that, it will look in the global scope. And also, if you don't want to use scope activity, you can implement your own Android scope component. That means that you have to, this is an interface, and you have to override the scope property here. And you use by activity. scope. And this scope will be used as a default scope for your activity with the by inject stuff. It avoids to reuse everywhere the scope object and say scope.inject, scope.inject, scope.viewModel. Then by default here we say, okay, this is my scope. Look at this by default, please. And if there is some of you that want to play with deeper things, we have also an activity retain scope that this is something that will retain everything in your scope backed by a view model. That means that everything will survive as like a view model then. Can be interesting in some cases. And for those who want to go in more adventurous stuff, you can have the ends directly in the scope API. You can ding yourself with the get Koin. You have access to Koin directly in activity like that. Get Koin, you can create your scope, and you can retrieve your scope with get scope. You can have an ID and then retrieve it. Can be interesting if you have a session or wallet, this kind of use case. Be careful to not lose yourself, and be sure to understand how you create and destroy your scope then. Last thing about scoped instance, perhaps the navigation graph that was not scoped until now in Koin. And then you have the Koin 100x navigation module that will appear soon in 3.1.3, where finally, for just a regular view model, and you just declare a view model here, you can ask this view model to be attached to your graph, to your navigation graph here. And then your view model will stay with your graph instance. Perhaps let's wrap up about scope. To define it in the Koin DSL, just have the scope block. You can use scoped instances to be kept in the scope space, view model. And also you have the Android API that is accessible here with scope activity and Android scope component. And finally, you can ding yourself with your end directly in the scope API, and of course, the navigation graph for those who want to do with that. It's time to talk about new stuff, especially with Jetpack Compose. I see there's many super shiny talks in DroidCon London, DroidCon Berlin 2021 here about Compose. And finally, you have an Android X Compose dependency if you want to use Jetpack Compose with Koin. And finally, Koin can be used directly in a composable function. That means that you can use get or by inject directly in your composable. And a good way to do that is finally to have your function parameter as a composable to use the default parameter value injected by Koin. That means that your composable is completely, by default, will use Koin, but if you want to use it manually, you can inject yourself the value that you want. And you have the same stuff with viewModel composable. That means that we have get viewModel and a by viewModel, and the same way, this is the first, let's say, the first API that are usable here to allow you to retrieve things directly everywhere in composable. We begin to fork the Compose samples application, and we have one of the first where we begin to play with that. It's not finished. I believe we need to go more deeper on the new usage that we will see behind Jetpack Compose. All the great improvement for Koin is that now Koin is completely multi-platform. That means that you can bring dependency injection, Kotlin dependency injection for your shared Kotlin code. Finally, you have your native UI code, and all your shared common Kotlin code can be declared with Koin modules. And then finally, you will use your Kotlin native API when you need it. One good application about KMP that I like is the one from John O'Reilly about people in space. I suggest that you take a look if you want a first project in KMP. It's about people in space. That means people in the ISS, the International Station. And if you open this project, you will see that you have the Android application, you have common code, you have iOS application. And in the common code, you will see that everything is declared with modules. Why? Because finally, Koin is pure Kotlin functions. And then you can declare all your common components directly with Koin. And then last, for example, we have the JSON part, we have the HTTP client part, the repository part, Kermit logging. And then behind that, John is using also some database storage on the mobile, then he's using SQLite. And we can have a special module. Here it's platform module that we want to declare. That can be expected. Then you have the keyword expect. That means that when we have the expect in common, we have the native implementation with the actual platform. And that means that we can have a platform module that is completely implemented depending on the platform you want to use. Then we have the JVM. We have also the iOS implementation. And then finally, you can declare everything in your common code. And in your Android application, what you want to do is finally just declare your view model because you are declaring your repository. And finally, that's it. You just need nothing else. All your common code is used by DI then. It's important to have this picture in mind because finally, you see that all the green stuff can be finally easily shared and then written with Koin then. Scaling with Koin is one of the questions I usually have with people around. And one of the stuff about Koin is how finally the Koin DSL is compiling with your code. That means that if you refactor something, it will refactor your configuration file with your module. Then it's living in the same place as your code. Then finally, there is a drawback with that, is that when you make a constructor, you update your constructor, then you have to update it by hand. And then finally, we reach some limits of the Koin DSL because it can be a bit boring to write stuff with all your DSL with the constructor, and then you have to put get and get and get, and you have a new parameter, you add a new get, and then say, okay, finally, for the easy stuff, it's not so fast. It's easy to understand, but it's not so fast. And then we need to think to something about a new proposal or something else. And until now, I was quite using any annotation and say, no, we don't want to reinvent things that already exist and now in a better way with yield. Then perhaps we need to look at something at the Kotlin compiler side. And Kotlin compiler, there's something that is super interesting today in the community that is KeySP. This is a project from Google where finally it helps you write Kotlin compiler first as an annotation processor, but not only. Then it will work at the compilation level. That means that it will be super, super fast, and then it can help you analyze stuff. Then say, okay, finally, could we try to find a trade-off, something, a new proposal to help the community to scale, because finally it's fun to use DSL, it's fun to write the stuff, but it's a bit annoying sometimes, and we can't use introspection to try to understand what you write at runtime, because it's just JVM. And today, in Kotlin, we can't use, in the multi-platform way, we can't use introspection. Then KeySP and perhaps trying to understand what you write at the beginning can be interesting. It's a proposal about using KeySP as a first Koin compiler. And then it's the first time I begin to share this project with people. And let's say people were interesting to say, okay, how could we do that with Koin and try to keep Koin API and keep everything easy? Let's go back with this to-do application, and let's see how it will go with the new compiler project. Let's go back with the definition. We have the tags data source, and what we can do is just add single. Nothing more. Nothing more, because we can understand that you have the type tags data source, and you have this instance that is declared as single, then a singleton, then we don't need more. We can bind everything for you. Behind that, if we have two classes for the data source, we just tag them add single, and we can add the tag add qualifier. It's super interesting because it's an easy way to tag your stuff with the qualifier and say the name remote DS and local DS. OK, fine. For the task repository, finally, what we just have to do is tag it with single, tag the needed dependency with the qualifier. And again, no need to make extra binding, no need to make extra things here. And when we want to bind it to wire everything at the end into the view model, what we can do here is we have an @Koin view model, and that's it. That's just it. Because finally, at the end in the UI, what we do is just buy view model, the old-fashioned Koin API, and that's it. Everything is working for you. And then it's a bit less annoying in terms of writing stuff, in terms of you don't have to write your get parameters into your constructor. Then everything is written down for you. And for the presenter side, we have also, just if you want to inject stuff, you can just tag @injected param. You can also have property. You can also have other stuff. And you will have the same API that is used here. Can be interesting. I believe we'll see how the community feels about that. In terms of module, we could have a module with all this in the DSL, but also we can write a class module to bring stuff. One of the problems of the Koin DSL is that it's completely runtime. That means that it's super hard to analyze really what you write in the DSL. And then it's hard for us to have to try to make meta programming over your definition directly in the DSL. What you can do here is have an add module and declare just on the function, make it add single. And then you can declare your definition here. And when you want to declare the DAO, you have something like that. Yeah, after that, it's just a matter of taste. I mean, like, if you want to declare things like that or just with the DSL, you can, and you can mix both. If you want here also, all these annotation can be gathered in a module. You can write everything. You just put add single, add view model, and then what you want to do, if you want to bring logically all those definitions into one module, you say just add module, add component scan. And you can also specify the package, mean that you can really filter everything, and then it scans everything for you, and then you have a logical module for you. At the end, when you have to start your module, how you launch it, finally your class, you just run your class with the constructor, and you have the dot module that is generated for you. And this is the only stuff that we are generating. You can use DSL module, you can use class module, and if you don't want to use module at all, we can generate a default module for you. The interest for that is that finally, one of the benchmarks on a very not optimized version is that for 1,000 components, it takes just 5 seconds maximum to generate everything for you. That can be interesting. It's super easy to debug because finally, what we do have here is that it's generated con DSL for you. And then that means that you can breakpoint, you can understand everything. It's not something that is super hard to understand because this is something you could have written, but then it's something that we write for you. And then the developer experience is really improved, I believe, like that. If you really want to throw an eye, you can check the Koin compiler playground project. Is where finally we are playing with the KSP compiler project, and then we are working on trying all the samples behind that. It's not yet online. And in terms of Kotlin compiler plugin, there is two trends, as you have the KSP code generation, that is an interesting project, and you have also JetBrains that is launching Reflection, another project that could help us make Reflection at the compilation time. Then I believe the story is not finished. And then DSL or annotation, it's really a matter of taste, a matter of how you want to be super fast in your code. Finally, it's not annotation to replace DSL. It's just another way that came to complete here the way that you can write your Koin here. I believe it's enough for me today. You deserve a good coffee. Just wrap up, you can use Koin 100, Koin 100X Compose, and Koin 100X Navigation in 3.1.3 in the next days. It will look at the web to see the updates. Soon, 3.2.0, the Koin compiler stuff. You can follow the project on Twitter and Medium. And thanks to all the community and people that continue to give the feedback, to continue to help, especially on Compose, we're discovering things. We discover more and more how we can bring stuff to the composable function. Special thanks to Stream that is also bringing financial support. The website, there's only one thing to keep here is insertcoin.io. And thank you for your attention.